Hello, and welcome to the Shotcrete 101 from Building Foundations to Retrofits conference call. My name is Maisha, and I will be your operator for today's call. At this time, all participants are in a listen-only mode. Later, we will conduct a question-and-answer session. During the question-and-answer session, if you have a question, please press star, then 1 on your touch-tone phone. Please note this conference is being recorded. I will now turn the call over to Frank Townsend, Vice President of Operations East with Superior Goodnight. Frank Townsend, you may begin.
Thank you. Good afternoon, everybody. We're here to give you an education on Shotcrete, on the basics. If you have any questions during the presentation, there's going to be a QA screen that's probably off to your right of your screen if you'd like to write those down. We'll try to answer what we can during the presentation. Otherwise, I'll kind of address all questions at the end. This presentation is brought to you on behalf of ASA, so all materials are copyrighted through ASA, so any permission to use these, you'll have to go through ASA to get that. American Shotcrete Association, the mission of ASA is to provide training, qualification, certification, education, and leadership throughout the industry to get the Shotcrete process equally accepted to form and pour concrete throughout the United States. What this seminar is going to be about is we're going to go through what Shotcrete is, the definition, the history of Shotcrete. I'm going to go through a whole bunch of different examples of the process and applications, and then go into a little bit of quality control, finishing, and ACI certifications, and we're going to end with references. So what Shotcrete is Shotcrete's placing concrete at high velocity. It's not anything different. A common misconception that Shotcrete's a different type of material. You're actually just shooting concrete at high velocity. And that's as defined as ACI CP 16, as you see on your screen there. The history of Shotcrete is it's not a new process by any means. Shotcrete is just one means of placing concrete. It started in 1907 by Carl Ackley, and then from there it's kind of developed through time into the Panama Canal, which was used for stabilization. Dry mix Shotcrete really took shape in the 1920s. And then in 1966 is really where wet mix really took form. What was a really revolutionary for the industry was ACI certification, which happened in 1990. There you can kind of see a box in that photo. And what that did was basically hold the certification standard, to hold quality for Shotcrete higher across the country and equal. And then American Shotcrete Association was formed in 1998. And that's really the education and the outreach portion of Shotcrete around the United States. So there's two different processes for Shotcrete. There's dry process and there's wet. Dry is typically what you would think of as gunite. So that nozzleman that has total control, he or she has control of the water-cement ratio. So you can kind of see the water goes directly to that nozzleman. Dry process is usually bagged goods. So you're looking at 50, 80-pound sacks or super sacks. From there, dry process is generally used in patch repair, small, thin, so 3 inches or less type of bridge repairs and things like that. And you're generally looking around 10 cubic yards a shift or less as far as volumes. Wet process is conversely different as far as the nozzleman now does not have control of that water-cement ratio. It's more of a high-volume application, more used towards structural end. So you're looking at volumes of 30 to 100 plus yards in a shift. And you can see the concrete just comes out of your normal ready mix truck, whatever you're using in your local environment that you have there. And like you're shooting larger foundations, you're looking at more of 1,000 to 2,000 square foot of finish in a shift. This here kind of shows you a photo of a parking garage. This would be a typical dry process repair job. So what you see here is kind of square cut edges, a roughened back surface, and you can see, the rebar, so you can get that concrete behind that rebar. Really, to get this thing ready to go is really all you need to do is surface saturate and then go on to a shoot, and I'll kind of get into that a little bit later in the webinar. Building retrofits are extremely common use for Shotcrete. So on the left side there, you can see shooting against waterproofing. So Shotcrete's very commonly used with Grace materials and other waterproofing products, as well as waterproofing admixtures. On the right side, you see another type of retrofit, just a building retrofit, structural going up. So the common use here is just think about moving forms on the floor. So if you had to move forms throughout all these given floors and form those form it up, brace it, kick it, bird's mouth and place it, what is that time difference? Where Shotcrete, you're going to get 1,000 square feet or more in a given shift. So, from there, it kind of changes the dynamic, and it really saves as far as costs in the retrofit market. This is another retrofit. Here you can see this is the Converse headquarters. This is actually up in Boston. What makes this photo generally unique is if you looked at that building, if you just said, okay, how long is it going to take me to get formwork to a given floor? How long is it going to take me to erect that formwork? From there, brace that formwork, place the wall, strip the formwork, rub and patch. You're going to get off a floor in about 4 shifts. So here, that whole wall that you see on a given floor, that would be 1 shift. So again, it's that time and that cost ratio. So if you're looking at, overall you have a cost-driven project, so something that's generating money, so high-end residential or anything that, that's, say, a rocket facility or something that, they're going to make money instantly, the quicker you can turn it over. Shotcrete's really the best alternative to get there. Another example of building retrofits, as you see in the upper right, is what the building looked like prior. The 2 photos on the left, it was 477 of 1-foot diameter columns throughout this building that need to be brought out to 3-foot with capitals on top, so you can get to the bottom right photo. That's how it looks today. This is in Lower Manhattan. But to give you an idea of those columns, we were shooting, I'm going to say 6 to 7 of them in a given shift. So if you just thought about, again, getting the formwork up, placing it, shooting, and finishing it, it's exceptional the amount of time. On this given project, it shaved 2 months off the schedule for the contractor. So it enabled them to get that superstructure up 2 months earlier, which saved them a ton of time throughout. Another example of retrofits would be bridge retrofits.
No.
You could see wet versus dry here. So what you see here is you see a wet photo up top. So the 2 photos up top, that would be the center over to the right. That would be a wet type process project. High volume. On this, you're looking 70, 80 yards in a shift. A foot to 3.5 feet is pretty common. Those were out in California. And then the lower photos are throughout Rhode Island and New Jersey. Those are more of dry process. So you can see, again, it's the square cut, the 3 inches or less, the roughened surface. And you kind of see the before and the after on that lower left photo. Those are the two of the seeing columns there. Another bridge retrofit. This is a 2.5-foot overlay. In this mix, you had all sorts of good stuff. You had waterproofing admixture. You had CNI. But you can see that the large scale, this is about a 3,000-yard placement, obviously over multiple shifts. Shooting about 100 yards in a shift, but shooting through more dense reinforcement. And from there, basically taking your time. You can see the one gentleman in the upper right. As far as the process, you're going to want a blowpipe guy and things like that, so you can blow your rebound out of the way, so you get a solid product all the way through. Another bridge abutment you can see here. These are 2 different ones. One is Virginia Beach on the left. The other ones on the right are in New York. But what you see on the left photos there, as far as pilasters, pin lines, as far as holding a finish and going through, you can see it's just as good, if not better, than form and pour. You don't have any form lines. You don't have any snap ties. And most importantly is you didn't have formwork up there. So you didn't have to bring formwork to the site, erect it, kick it, and then go through and then say, okay, now you have to design your formwork. You don't have to design any formwork. Shotcrete's just a great answer to one-sided applications all the way through. The one on the right is a little bit different. So you see it's about 26 feet in height. Through that, it's about an 18-inch thickness on that wall. But most importantly is if you look at that far right photo, and just below it, that's a detail of what that is. It's actually a 1-inch by 1-inch groove pattern all the way through. It was originally designed as a form and pour placement. The forms were actually over-vibrated. So what happens, they brought too many air pockets out to the front surface. So when it was stripped, the contractor, and this was actually the New York DOT, wasn't happy with the results. From there, they knew, and they said, okay, let's look at Shotcrete. And then from there, went through, and it's an easy way to do it because you can watch the encapsulation happen as you're shooting up. And then from there, we have wires, and I'll kind of talk about how we get finishes and things like that a little bit later. and use those wires as grade lines, and we use jigs basically to cut it down to get that 1-inch by 1-inch pattern that you see. Canals and aqueducts are another great application for Shotcrete and extremely across the country used, from oval culverts that you see in the upper left to water, just different water drainage basins run through from Nevada to New Jersey, all over. These are common. And then if you look in the upper right, you have really tight spaces. So if you're looking at that tight space and how would I get formwork in there, how would I brace it, how am I going to place that, it's really a logistical nightmare versus, you can go in there literally on a little buggy, and from there, you're shooting out 100 to 200 lineal foot of this in a given shift. So it's that, again, it's the time and cost savings with Shotcrete is where it's a great application. Marine structures is another one of the most common applications with Shotcrete, just because you can play the tides a lot better. As the high tide recedes, you can come in and you're looking at this from all the way from the upper left all the way to the lower right in one tide cycle. So you can come all the way through, and throughout the tide you can shoot it. This one pier that you see there took around 10 yards. And with there, you can shoot it through, you can finish it, you can get a higher release strength on it, and then you can seal it before that next tide comes on. It's used all throughout the United States for this type of work. Dams is really, the Corps of Engineers really brought dams into play around 1970 as far as repair work. And you kind of see that more and more. I think everyone's seen all the flooding throughout the Midwest. So between dams and locks, Shotcrete's a great answer for that one-sided application. And most importantly, it was used on the Orville Dam most recently, about a year ago, that Kiewit did. As you can see, I think everybody kind of knows what happened at the Orville Dam. And with that, as Kiewit was looking at how quickly can we get these walls up so if something happens, we can open up the gates and we can get this functioning again. And from there, they looked at it, and through the Shotcrete process, they were looking at around 2,000 square feet of finish they were getting a shift. So you multiply that out, and it just kills as far as time. Tunnels are used all around. I'd say more overseas than in the United States right now for final linings. This one here is in New York. So what you see here is the left-hand side of the photo is a running tunnel. Using the Foreman pour process, it was about a 3-day turn. So they were getting 32 lineal foot of tunnel. It was a 24-foot diameter tunnel, and they were getting 32 lineal foot of tunnel done in 3 days. Through the Shotcrete process, we were doing 64 lineal feet of tunnel in 8 hours. So obviously you kind of know where that went. So it wound up being quite a bit of work. All in about 100,000 yards in that project. But you can see the versatility of Shotcrete, and again, the most common trend that you're going to see throughout this whole thing is one-sided walls, one-sided walls, one-sided walls. Here again, you see shapes, shapes that would just be astronomical to form and pour. So if you look at the carpentry to form these up, and it'd be a one-time use, not really lead-friendly, just astronomical as far as costs. Where Shotcrete, it lends the flexibility of shapes. So here, obviously no formwork used short of the box outs that you see on the lower photos. But that lower photo kind of shows you a unique application with Shotcrete on a two-sided application, where you can place stay form in between the two mats of reinforcement, and you can treat a two-sided wall as two one-sided walls and shoot both sides. You can see the finished product off on the right there. This is another example of shooting a two-sided wall in one. This is an access issue. So this is down in the tunnels as well. So you see that 2-foot thick shear wall down the middle. It was designed as form and pour. And the forms went up, and the kickers went. And then from there, obviously, there was a few people that were concerned because there was no access through and past this point. From there, those forms came down, and then Shotcrete both sides as far as two one-sided walls. As far as production-wise, we're getting about 1,500 square feet in a shift. So again, it's the production was 2 to 3 times what the form and pour was. But most importantly, is it allowed access. So it allowed ease for egress, for safety means, as far as, and then it's also for materials and logistics to pass through. So there's difficult situations with logistics that can really solve those problems for you. Soil nail applications are extremely common, usually done in 2 applications. So your initial lining is going to be a rough or prepared surface. And then from there, you're going to get that final face that comes on. Here you can kind of see the final face going on in the upper right on a soil nail wall up in Connecticut. But, soil nail walls, as far as soil retention in general, sometimes these are done in 5-foot lifts, so you cut through. The biggest thing to be mindful of is that production, how you manage that crew. So do you take the Shotcrete crew and turn them into laborers because you're only going to get 500 square foot in a given shift, or it's really something to talk to the Shotcrete contractor that you're going to use to share that knowledge and to share the workforce to make it as economical as possible for you. Foundation walls are extremely common, and I'm going to tell you they're very, very common on the West Coast. The East Coast, I think, is slow to go, but it's definitely going. The upper photo there is you see the Staples Center. I would tell you that there's very, very rare to see in the whole West Coast from California to Washington State to see forms in a hole. There's hundreds of Shotcrete companies out west. That's all they do is they go and they shoot these foundation walls all the way through. Again, it's the cost of the formwork and it's the speed as you go through. The lower photo is Hudson Yards. And what makes this really unique is, okay, so you're out of the ground. That's great. You see the pilasters. You see the pin lines. It's 12,000 PSI concrete. So, one of the misconceptions I think that's out there is Shotcrete's an inferior material, and you're going to get lower strengths, which is absolutely not correct. I will tell you to get 4,000 PSI Shotcrete is actually a very difficult task because it's too low. Shotcrete, a general mix, is probably going to break around 6,000 or more. As you can see on this one, this is 12,000. It's on the high end, to be honest. But what makes this photo sell a lot of photos sell some work is it's in New York. And the most important thing is look at the tower crane. You can see the first section of the crane is there, and the crane is not up, and you're out of the ground. So what's the price of not needing the crane to get out of the ground? It's pretty, it's an exponential kind of thing. As far as the lay down for Shotcrete, you're looking at about a 2-inch system that's going to run through. So as far as intrusiveness, it's minimal to none. You're looking at scaffolding for the wall, and then that 2-inch line that's running through. You can go up, you can go around, you can do box outs, pilasters, whatever you want. But what is unique about Shotcrete, and one thing to understand, is it's a rub surface. So you're not going to have form lines. You're not going to have the undulations of the formwork moving. You're actually going to have what the finisher's finished. You're actually going to see the stroke of the finisher, that worked that circle to go through, and you're going to see a good rubber float finish as you see through. Foundation wall. Here's another. This is a Domino sugar plant. This is again. This is in New York, looking at Manhattan. So if you look at the lower photos, each one of those apartments are god awful, probably over $1 million an apartment. And this is the speed of construction. So as you go through, we looked at this foundation against form and pour, and lo and behold, we were quite low as far as contract value. But more importantly, we made money on it, which is a good thing. But more importantly is the fact that we did this entire foundation in 10 days, where form and pour was looking at 2.5 months. So what's the time? You just saved a month and a half plus on your schedule, and each one of these apartments are $1 million. Well, now you can get into these apartments quicker. Your clients can make money quicker. So the cost of that is worth exponential. This here is a basic retaining wall, and it's nothing sexy going on in these photos. But there is something sexy about it. And what it is it's not the guy that's there. It's the 7 o'clock in the morning in the upper left-hand photo. It's 2 o'clock in the morning or 2 o'clock in the afternoon the same day in the lower right-hand photo. That's exponential. If you look at your normal job sites, you're going to have formwork still there. You're going to have kickers. You're going to have form ties. You're going to have all sorts of stuff you have to deal with a day to 3 days to 7 days afterwards, where you're walking off the job and now you got your MEP engineer saying, hey, when can I start hanging stuff? It changes the dynamic of a project. Other shear walls you can see is Los Angeles Police Department in the upper photo there. You see that radius shape on the upper left hand. That's Stateform in the middle and shot both sides. So pretty unique, and if you look at that, that's a one-shift application. So again, if you're looking at formwork how do you get it in, how do you brace it, how much are you tying up as you're going through it, versus if you have the flexibility that you can just go in, shoot this, and then keep on moving. It's pretty unbelievable. The lower photo there is the World Trade Center. You can see those shear walls all the way through. It was about 14,000 yards shooting against Stayform, and what that did is it allowed Tudor Perini, who was the general contractor, to go through that without a crane access and get through that. Shear walls. This is actually Tower A of Hudson Yards. The core of the building all the way up was concrete all the way through. And then from there, they looked at time access, and they said, okay, we're going to backform the core of the wall on the inside, and it was shot. Columns-wise, I'm not going to tell you that Shotcrete is the best answer. But what you can do is, if things like this happen in the lower left-hand corner where the top and the bottom are already placed, here it kind of gives you an example. As you can shoot, here these are 22 foot in height, 24-inch diameter columns all the way through. And then from there, you can shoot about 7 of these in a shift. How it's done is by placing wires and using a jig and to cut that jig all the way through. And then from there, you cut those wires out, and then you hand finish all the way around and through. Smoothing over secants smoothing just in general is a very common use for Shotcrete. This is the Gateway Tunnel in New York, but you can see it's a 5-foot fill, so 100 to 300 yards in a shift that you're pumping out, and it's really to get that smooth surface for the waterproofing. Or you have the secants like you see in the lower photo that you're smoothing on just to get that final flat face all the way through to fill those undulations. Smoothing over sheet pile is another use. Here you can see in between those sheet piles you have a 4-foot fill through there. So it's how do you get that flat face all the way through? Again, Shotcrete through that, the one-sided application. Just go up on the smoothing side. You can basically go off of man lift, so your production goes way up. Here you're looking at probably 2,000 to 3,000 square foot to finish in a given shift. Pools are the most common use of Shotcrete around the United States. There are certain contractors for certain type of work, as you see. There'll be pool contractors, there'll be dome contractors, there'll be skate park contractors. I'll kind of touch that in a little bit. But the most ideal situation is to, get the history on the type of work that you're doing, and get the history on the company and say, okay, is this a pool contractor? Is this a pre-stressed tank contractor? Is this, do they do storage domes? Whatever it might be. So, get the history that you need for each one. Pre-stressed tanks are another use of Shotcrete. Again, it's that one-sided application, that ease of construction if you had to use formwork to place these and go around. Just the price would be unbelievable. So if you look at with Shotcrete, you have the flexibility that you can move, you can shoot, you get yourself all around there and get the finish of desire that you want. Storage domes are also a very unique application for Shotcrete. Different ways of doing it. Sometimes you shoot it from the inside, sometimes you shoot it from the outside. It's pretty interesting. Some of them are built with basically you blow up a balloon, rebar goes on, and you walk the rebar and shoot it, and then you deflate the balloon. But very great application for Shotcrete all around the world. Bobsled runs are one of the claims to fame for Shotcrete. I know everyone's kind of sitting here looking, going, wow, why bobsled runs? Bobsled runs are unique because the fact is the radiuses continually change. So if you thought about forming this is off the ground, and there's no radius that stays the same. It turns all the way through. And if you thought about form lines or something like that, that was, if you had a form line and you had a half-inch gap and you got a gentleman like me, 200 pounds, flying down on a little sled and they hit a half-inch gap, big problem. So, you're looking at, keeping that perfectly flat surface and the formwork. With Shotcrete now you can just shoot that and you can finish it all the way through. And most all bobsled runs all around the world are through the use of Shotcrete. Skate parks, again, you have these unique radius structures. So if you thought about forming these and working these, it would be unbelievably expensive. Skate park contractors are excellent at what they do, and you can see the beautiful shapes that they can create. With Shotcrete, there's numerous types of finishes. What it is it kind of gives you that open face that you can do anything you want with. You can see a nozzle finish that you see in the upper photo. A gentleman in the middle there is rotting, and the tiki there that you see on the bottom that's actually hand carved. So there's unbelievable talent out there as far as the different things that you can do. Here's 4 different shots of the most common finishes that you see. Gun, mostly you see at the geo level as far as earth stabilization and such. Rod is your basic cut finish, so you're just going to get to that grade. You're going to cut it off. It's going to be dead flat, but it's going to have, basically you're wholly through. And then sponge float, rubber float, that's probably your most common. To give you an example, what a rubber float is it's basically like a gritty sheetrock. So it has that roughened look to it as far as texture-wise. So it kind of kills the light. Where if you look at the steel trowel is very shiny because it brings all the moisture out. You can do unique things as far as carving, stamping, anything you want with Shotcrete. So most of your zoo exhibits, rock wall carvings. If anyone's been to Disney, a good chunk of their work down there is all Shotcrete. So it's basically shot and carved concrete all the way through. And you can stamp stuff like you have the board finish down in the lower right. So for the architects out there, it kind of gives you that great perspective through. Or you can color and you can stamp it. So this is a darkened concrete, obviously, and then from there you can these hexagon stamps that you can go everything through here. There wasn't a stitch of formwork used to include the drainage as you see down in the lower left there. Or you can do things like this, unique wine cave, colored, stamped, anything that you want you can kind of create in freehand. The gentleman on this one actually was stamping things into the wall, like prehistoric stuff. So you can do anything you want as far as creativity, like things like this. You can make these beautiful rock shapes that you would swear that, oh, that's a natural rock creation, but in reality it's not. That's a Shotcrete carved, stamped, and stained. Sustainability with Shotcrete is, I hope that you get, is it's reduced formwork. So it's limited to no formwork. As far as equipment needs, there's really nothing. You don't need a tower crane. It's basically you have a tow-behind pump, a compressor. So if you're going to go wet mix, it's going to be more of a 375. If it's going to be dry mix, you're going to be larger. You're going to be more of a 750 CFM compressor. But for the most part, the laydown area is generally small. You don't need generators. As far as access and flexibility, as I mentioned, you're going to have a 2-inch line that runs through the site. So it's pretty quick. It's as far as moving things around and such. It's not, you don't have a boom truck tied up. You don't have your tower crane and things like that. As far as bonding, again, as the first slide showed, is you're shooting concrete at high velocity. So a ballpark, let's say 60 to 80 miles an hour. So with that, you're going to have a better bonding. And I'm going to talk about that bonding here shortly. And then you can do the creative shapes. So you can do the curves, the domes, and all sorts of different things where formwork might be very, very expensive. So with environmental conditions, hot, cold, all the same as normal concrete, right? There's nothing that's really jumping out that's the same as what you're going to have for form and pour. The one thing with Shotcrete that you have to be mindful of is wind. As far as with wind, reason being is you're going to have wind that could come across your final face. From that, it could wick moisture off your front face of your application, and then from there cause surface cracking. Or it could be, if it's high winds, from there it can splay your placement, and from there you won't get good application onto your surface. With surfacing, you want to get with prepared surface. This is I kind of showed this earlier on the dry process, where you want to. This is kind of the upper photo kind of says it all. With the removal, you want to get square cut. You want to get 3 inches deep. With that, you want to be able to get behind that reinforcement, as you kind of see the lower diagram showing that. So there's definitely no feather edging. You don't want to do that. And also with preparation is you don't use bonding agents with Shotcrete. Reason being is if you put bonding agents on, that bonding agent is going to wind up just getting niched off over time because, again, you're shooting concrete, which has aggregate in it, at 60 to 80 miles an hour, and it's going to take that bonding agent off. The best bond for Shotcrete is just surface saturation. So really you want to get that roughened surface, and then you want to saturate through. So the big question a lot of you might have is what about cold joints? Because this is probably a photo that most people have seen on their different projects throughout Form in Place. With Shotcrete, this can't happen. Reason being is I think everybody knows what the definition of a cold joint is. So it's where basically you place one layer, and then from there a duration of time went by or the concrete went off, and you can't blend the two, so you don't have your vibrator there mixing those two together. With Shotcrete, that doesn't happen because you're blasting with high quality and high energy. So that high energy is causing abrasion onto that roughened surface, which is surface saturated, and then from there it niches in and then places through. So, you're going to get bondability all the way through. And if you do have to stop, God forbid, as, you're doing a placement, and let's just say the trucks are too far away and the trucks aren't coming in, what you can do is you can stop it, drop it on a 45-degree angle on your receiving surface, and then prepare the surface. And what that means is you just want to keep it rough. So, a typical tile trowel is what we use, but you want to get a rough, prepared, clean surface so you don't have any voids or gaps or anything like that, so you can, the next day or whenever you can pick back up, you want to surface saturate and then shoot right back onto that surface. Formwork-wise, I promise you that everybody on this phone call can hold up the formwork for Shotcrete. Why you can hold it up is because most of Shotcrete is done through bench shooting. So what that means is you're actually shooting back into the material. The material is the receiving surface. That back form is just simply to hold it, so you don't need this, extensive engineering design, to hold that back form. I mean, obviously it has to have some rigidity to it, but for sake of emergency, if you had to put up a piece of 3/4-inch plywood, hold it up and hold it for an hour and a half, you could shoot against that. Again, you're just going to shoot back into the material and build your way up. So you'll work your way around a given surface. So if you're going to shoot a foundation, say, and it's 200 feet around, you're basically going to go up, 3 to 5 feet in one lift and work your way around that base and go up on the next level and work it up, and then work it up and work it up. You're not going to, take the bottom layer and go up 30 feet and then work, 5 feet away. So you can see that the form and pour radius application on the left, you can see the complexity of that, and this kind of just, proves the point of, you can see the very light formwork that's used for Shotcrete if you had the backside, one side application as far as formwork on that on the right. That formwork went up, it was placed and removed all on the same day. Reinforcement-wise, it's whatever your contract design is you can use. Non-contact lap splices are sometimes preferred depending on what the application is or the situation. In general, it's generally fine as is. But what I would tell you is that lap splices is the key to using Shotcrete or not. Shotcrete is not the answer to concrete. It's not form and pour. You're going to still form and pour your decks. If you have columns or you have open foundations, you can get 2 forms to both sides. It's probably the best way to do it. But one-sided application, Shotcrete's great. If you have number 11 rebar at 3 inches on center, I would tell you that's a great self-consolidated concrete job and not a Shotcrete job. Reason being is we have a 2-inch nozzle, and we want to be able to get in and around all those surfaces. No different than, you're going to have to look at different means of placement the thicker the application gets as well. So a pretty typical structural Shotcrete is probably 2.5 feet on in. Once it gets outside of 3 feet, you want to look at alternate means as far as getting good encapsulation in that back. The best way to do that is to go through Shotcrete testing, and I'm going to kind of go through mock-up here very shortly. How do you get alignment control? This is how, a lot of people say, well, how do you get a flat wall? How do you make it perfectly flat? How can you guarantee it? So what's set is wires are set for flat walls, basically 3 foot on center. The nozzleman uses that as a guide control to shoot to that wire. From there, you cut off those wires as far as with a rod. I think there was a photo of it earlier with the finishes. And then with that, you cut those wires out and then you finish over those. So you have a dead flat wall. You don't have that formwork moving. And then you can also use pencil rods and radius structures. You can use depth gauges if you're looking at, earth structure, if you're looking for the geo application, or different guide strips and formwork throughout. This kind of shows you typical Shotcrete mixture stuff. This isn't a mix design by any means. What this is just a guide to say that everything that's in your Foreman pour is in Shotcrete. Everything from the different pozzolans to high-range water reducers to fibers, steel, poly, synthetic. One thing to make of note is the water-cement ratio. I will tell you if a 0.45 Shotcrete mix or higher was brought to a job, it'd be tough to stack. So you're really looking at low water-cement ratios, which is great for engineers as far as quality control. Ideally, a slump of less than 5 inches, really ideally 3 or less, depending on what the system length is. But you really want that tight, low water-cement ratio so you can stack quickly on top of it. As far as aggregates and gradation-wise, gradation 1 is for the fines, gradation 2 is coarse. You're basically looking at 3/8 inch as far as your aggregate. And dry process would be less, so you can go through that. Also with Shotcrete, you can use all sorts of different additives. So super plasticizers, retarders. I kind of talked about the fibers. A lot of stuff is waterproofing admixture, not a problem. So anything that, again, you can do with your Foreman pour, color, you can do with Shotcrete as well. With Shotcrete, there's a few things that you can do and you probably need to do, and also you have to be mindful of is set accelerators. What that is with wet mix application, you can apply an accelerator at the nozzle tip. So it's a good thing and it's a bad thing. What the good thing is if you have a retarded mix or you have a high-range water reducer and you have a lot of retarder in it, and you put that concrete to sleep for, say, 3 hours, how do you turn it around? You can turn it around through the use of accelerator, and you can dose it at that nozzle tip to kind of help you gauge that. But it's really something that needs to be monitored because too much accelerator can also make the concrete very brittle. Quality control-wise with Shotcrete, mix design is generally the best as far as performance-wise. Ideally, it's tested at the point of discharge, but not always. ACI certification, I will tell you, is probably the most important thing to all of you on this phone. Any project that you do, I promise you need an ACI certified nozzleman. It's like jumping in a car with somebody that doesn't have a driver's license. It's just a really bad idea. I'll show you some photos of that coming up, and we'll go through what ACI certification is. But some of the key takeaways is ACI certification is a must. And if you're doing concrete against one-sided applications, you really should be looking at Shotcrete. With the Shotcrete process, test panels, mock-ups really should be done at all levels. And I'm going to kind of go into that right now here coming up. So this kind of gives you an idea of pre-con testing of 2 different projects. So what needs to be tested on a given project is the worst-case situation. So you need the worst rebar configuration, the longest pumping distance, the worst weather, whatever it might be on that given project, that's what you should be testing at that mock-up. If you have normally 600 foot of pumping distance that you need to pump for the project, and you go do the mock-up and you have 100 feet of slick line and a hose on, that's not a good test. You also should do the worst rebar configuration. So you look at the lower left project. Those are number 11s. Is up in front. You can see the encapsulation of those 11s, which is the saw cut right to the right of it. You can see the lap splices in the back shooting through. It's a 2-foot thick section in the back. It's 18 inches on the left there. But it proves the encapsulation, and everyone has the common misconceptions. Oh, there's sand lenses, and there's going to be shadowing and things like that. The mock-up proves that. With that, the mock-up should be shot by the ACI certified nozzleman that's actually going to shoot the project. So whoever is shooting that mock-up should be the one that's shooting your project and shouldn't be substituted out. Another example is you see the column on the right there. Those columns are shot in one direction through 4 mats of reinforcement. Again, not for the faint-hearted. It's not that any ACI certified nozzle can do that, but it's something that you want to test on your jobs as you go through. From there, cores can be taken, so you can saw cut or cores, and then from there it can be evaluated. So the engineer on the project or the design team can sit there and look at it and say, okay, I like the encapsulation, I like the way that looks. Mock-ups should also be used for color and for finish as well. As you're going through projects, production testing is done, and from there, where you're used to doing cylinders, with Shotcrete, what you do is you actually shoot boxes, and then from there you core the boxes and you break the cores. So you're actually getting the nozzle that placed it, the weather, instead of if you just did cylinders, you're going to get 3 cylinders that were done early in the process. From there, the testing's done, and quite typically, then the truck gets watered down and then off it goes. And it's not typically the same mix that you tested. So you really have a perfect mixture versus reality, where this Shotcrete testing really gives you more of a true test through. Quality control with Shotcrete, you can do all the same stuff. So compressive strength, flexural beams, toughness, permeability, anything that you would do with your normal material, you can do the same type. I showed a lot of great pictures of what you can use Shotcrete on all these one-phase surfaces. But with Shotcrete, inherent is rebound. And what rebound is basically it's the ricocheting of aggregate that comes off that back surface and throughout the reinforcement as you're placing your wall or whatever it might be. That aggregate gets kicked back. It should never be used. To say that there's a Shotcrete project that has no rebound, there's something wrong. From there, that aggregate or that rebound needs to be removed, bagged, and taken off-site, or not used in the placement at all. Typically, rebounds could be anywhere from 3 to 20%, depending on what your applications are. And that's something also you'd be testing at the mock-ups. You're going to see what that rebound is as you go through. Curing of Shotcrete, obviously it's concrete, so it needs to be cured. Wet curing is the best. Spray curing with Shotcrete is probably more common because you have that open face. You want to close and seal that concrete. So from there, you avoid surface cracking and things like that, or minimize them. And it's, again, with spraying with curing compounds, just be mindful. It's 2 applications in each direction. It's not just nilly-dilly and spray it on. Requirements for ACI certification, it's not for the faint-hearted. So as you go through nozzleman certification, there's a 1-day mandatory education through ASA, and it's a great education program. Somebody from ASA will come in and they're going to educate your nozzlemen that are going to be taking the exam. To take the exam, you need 500 documented hours, or if it's less, you can apply for a nozzleman in training. And then from there, that'll get processed through ASA. And at that point, a written exam, an oral, a practical will be done on site. What that practical looks like, as you can see the lower photo, those circles just give you, where cores will be taken generally. It could go on either one of the faces. And each certification is for each type of application, so wet versus dry, overhead versus vertical. So just because, for example, myself, I'm wet mix vertical and overhead, that doesn't mean that I'm certified to grab a dry gun and start shooting because I don't have my hours. So, as you go through, this is something you can look on aci.org, go to certifications, and you can look up anybody's name and find out what their certification's in and how long it's good for. This gives you an idea of ACI certified nozzlemen to the right, non-ACI certified to the left. So obviously, I think everybody knows you want the one on the right here pretty easily. As you're going through and you're looking at your projects, going through and you're looking at foundation walls or one-sided pits or soil nail applications or pools, whatever it might be, this is kind of some basic things you probably want to look at. You want to look at what's the history of the contractor that you're choosing. Do they have a background at doing it? For example, is if you called me at Superior Gunite and said, hey, Frank, we want you to do a dome, I would tell you that I'm probably not the best guy to do it, and you probably need to call ASA and get some qualified contractors through ASA that just do domes. No different than pools or skate parks or whatever it might be. You want to get the history on what those contractors are and the nozzleman. So, what history is a nozzleman? Was he just certified, or was he or she just certified, or they have it for 5 years? Have they shot this type of application before? Do they have the skill to do this? Some other useful tools and resources. Shotcrete.org is ASA's website, and the buyer's guide there is great to use if you don't know much about Shotcrete. ACI certification, I just talked about that one. ASA is a main office. ASA is a great resource for Shotcrete. They have the phone number there, as well as both email addresses. A lot of you might know Charles Hanskett. He's the executive for ASA. He's very well known and throughout ACI and ICRI and other organizations. Wealth of knowledge for Shotcrete. His whole life has been in the industry. Other references for Shotcrete, ASTM covers Shotcrete, so you can see between materials and testing, all these, different. So if you're looking at, okay, how do I take panels for testing? That's all covered through ASTM. And then ACI also covers Shotcrete. ACI 506 is what is Shotcrete. From there, but most importantly, is 318 and 301 just picked up Shotcrete as well. So now in the past, when you're looking at structural applications, you're saying, okay, I got to do the presentation, the song and dance to try to get Shotcrete approved as a VE or whatever it might be for that application. Now it's in code. So from there, you can say, okay, go look at ACI 318.19, and you can see that Shotcrete's acceptable. So it kind of opens that path for that one-sided application to help everybody out. So the big question for everybody is, so what? What you see on the left is a one-shift placement of Shotcrete, rub to finish all the way through. To the right is a 4-day or it's really 2 days of placement of form and pour. But between the forming and stripping and everything, and you still have, look at all your lines. So there's still a lot of things that need to be done to dress that up. So the biggest thing I want to leave you guys with is Shotcrete is not the answer to concrete. It is great for one-sided applications. It's good for some two-sided applications. No different than, if you're going to drive a nail into wood, you're not going to use a screwdriver, you're going to use a hammer. So, you have self-consolidated, you have form and pour, you have Shotcrete, so there's all different means of placing concrete. And Shotcrete's really, the answer to that one-sided application. So right now, I'll take questions. If anybody has any questions, please feel free. So one question I have here is the material you're shooting, you were calling concrete? Is there aggregate in the material? Is that why you are shooting with such high CFM and large diameter pipe 2-inch? That's correct. Yes, we are shooting concrete. It's just 3/8 inch aggregate instead. You're using 1.5 to 2-inch line all the way through, so yeah. Another question I have here is what type of pump are you using for this application, piston or toe behind? We're using a piston toe behind pump, yeah, but through dry process there's a litany of different pumps that you can use. But for wet process, yeah, you're going to use typically you're going to be using a toe behind pump. And that's all I have for right now. Does anyone else have any questions?
Would you like to take audio questions at this time?
Sure.
Thank you. We will now begin the audio question and answer session. If you have a question, please press star, then 1 on your touch-tone phone. If you wish to be removed from the queue, please press the pound sign or the hash key. There will be a delay before the first question is announced. If you are using a speakerphone, you may need to pick up your handset first before pressing the numbers. Once again, if you have a question or a comment, please press star, then 1 on your touch-tone phone. And we're now awaiting any questions.
I have one question here that just came in as far as typical crew size. Typical crew size is going to vary, and why I say it's vary because you could be in New York where you need 2 operators on a pump, and different things, which is, pretty outrageous. But if you're looking at a typical, earth retaining nozzle finish, you're probably looking at around 6 personnel. If you're looking at a high finish, you could be up to 12. So, you're looking somewhere in between there. Another question that just came through is Shotcrete tolerances. The tolerances for Shotcrete, like I said, it's going to be better than form and bore because you don't have the undulations of the formwork. That formwork's not going to move because what we're doing is we're shooting wires, and from there, those wires are going to stay in place. You're going to finish it, and then from there, you're going to cut those wires out and finish it off. So as far as its tolerances, it will meet or beat form and bore tolerances.
We have no audio questions at this time.
Okay. Well, thank you very much. I hope everybody has a great afternoon. If you have any questions, please feel free. You can reach out to myself or you can reach out to ASA, and I will put their resource right on the page so you can kind of take a look at that for the last few minutes. Thank you.
Thank you, ladies and gentlemen. This concludes today's conference. Thank you all for participating. You may now disconnect. Presenters, please stand by for your post-conference.